x equals 0. This is x equals 100. So they don't start at the same time. They don't start at the same point, rather. So runner A starts at the starting line, right at x equals 0. But runner B starts at, say, x equals 8. So runner B gets an 8-meter head start. Okay, and we know the velocities of the two runners. So the velocity of runner A, who does not get the head start, is 2t. So his initial velocity is 0. So he starts at rest. And the guy who gets a head start, his velocity is always 2. So he starts at a velocity of 2. We'll say meters per second, whatever, it doesn't really matter what the units are. So first, so who wins the race? It's the first question. So they do start at the same time. One guy just has a head start. That's all. When it goes, ready, set, go, they do go off at the same time. Just runner B is already 8 meters ahead. And then part B. So whoever wins, how much of a head start should the other guy have gotten so that they tie? How much of a head start should the loser of the race have gotten to ensure that the two runners finish at the same time? That's an interesting question. In other words, how much of a handicap does the one guy have to give? Okay. So I'm going to give this to you to think about it for a few minutes. So all I really do, I'll tell you, this is in the antiderivatives section. This is from section 4.9, right? Antiderivatives and initial value problems. So think about that. Think about at least how you would figure out part A. Think about how you would figure out who wins the race. Okay, so let's think about part A. So how did you think about solving this problem? What type of what information did you need to solve part A, and how do you get that information? Okay, so Justin says we need the position of the runners, right? Exactly. So if I can figure out the position of the runners for any time t, then that'd be good, right? And how could I figure out the position of the runners? Well, it's really an initial value problem, right? What am I given? I'm given the velocity of each runner, and I'm also given the starting point of each runner, right? A point and a derivative. So I should be able to get the position right as an initial value problem. So let's get that first, and then we'll solve parts A and B. So we get the position of each runner. Oops. First, right? We have two IVPs to solve. So let's look at runner A and look at runner B. Okay, so for runner A, what can we say? We can say that runner A, okay, the position of runner A, we know if you're given the velocity, how do you get back to position? You take an antiderivative to get back to position, right? So the position of runner A is the antiderivative of the velocity, right? So that is the antiderivative of, and what was the velocity for A? It was 2t. So the position of runner A is t squared plus some constants, which I'll call CA, right? Because both runners are going to have their own constants and they're not going to necessarily be the same, right? Now for runner B, the position of runner B, same thing. It's the antiderivative of runner B's velocity, which in this case is just 2t plus CB. All right, so let's put kind of a vertical line down the middle so we don't get confused here. Now, how do you find the constants of integration? So for instance, CA. So let's see. So Yana says set antiderivative equal to initial position while substituting in 0 for t to get the C value. So very good, right? So we are given that, for instance, XA of 0, where does runner A start? Runner A starts at 0, right? There's no head start, right? So this tells you what? This tells you 0 plus CA equals 0. So CA equals 0. And we're left with finally, so the position of runner A is just t squared. That's it. And the same thing we could do for runner B, right? Runner B's position at 0 is 8. Right, he actually gets a head start. So substituting in 0 into my position function, I get 0 plus CB, but it's supposed to be equal to 8. So obviously CB equals 8. And I can see now that my runner B position is equal to 2t plus 8. All right, so Yana wants to solve the whole damn problem for us. That's great. So let's get rid of some of that. Okay, so then Yana says, for part A, who wins the race? And it says, well, set both equations equal to 100 to get t values, right? So that's correct, right? So what I'm going to do is by setting each equation separately equal to 100, I can now figure out how much time it takes for each runner to actually finish the race, right? And obviously, whichever runner takes the smaller amount of time won the race, right? Like how long does it take them to get to 100 meters? Okay. So now we find out how long each runner Now we find out how long each runner takes to win the race, to finish the race. Okay, so how long does it take runner A to finish the race? So runner A takes 10 seconds to finish the race. Like I told you, these are not real human numbers. How long does it take runner B to finish the race? Let's see, 100 minus 8 is 92. Divided by 2 makes 46 seconds. So what do we conclude? We obviously conclude that runner A won the race, right? Because runner A takes only 10 seconds to get to 100 meters, but runner B would take 46 seconds to get to 100 meters. Okay, so now let's look at part B. So part B asks, okay, so consider now the loser of the race. The loser of the race was runner B. We know he already got a head start, but let's say, okay, what head start did we actually have to give runner B that the two would actually finish at the same time? So runner A gets no head start, runner B does get some head start. How am I going to figure out how much of a head start runner B actually needs? Let's say you could plug in 10 for T and solve for initial position. Okay, good. Right. So first of all, we're not going to use the same position for runner B, right? We're going to assume now, let's say he did not start at 8. Let's say runner B started at some arbitrary value, right? 10, 20, whatever. So it's a slightly different position. So suppose runner B starts at, say, x equals whatever, x equals d, right? Right, then if we go through the whole thing again, we know that x b of t, his position is 2t plus d, right? Where d is the head start, right? I just want to kind of make that clear. D is the head start. And so like Agana and Jessica have said, right, we're now going to set this equal to 100, but we already know t should be equal to 10, right? Because runner A, nothing has changed with runner A. Runner A still takes 10 seconds to finish the race. We want runner B to also take 10 seconds to finish the race. So that means at t equals 10, runner B better be at 100. So if the two runners tie, we have that xb of 10 must be equal to 100, right? At 10 seconds, runner B is also at 100 meters, just like runner A. So we get here 2 times 10 plus d must be equal to 100, and solving for d gives me 80. So if you want these two runners to end the race at the same time, runner B actually needed an 80-meter head start. A little ridiculous if you think about it. But. Okay. So again, notice how in part B, we're actually making that initial position a variable, an unknown or unspecified constant, right? That plus 8 is now a plus d. And then we go back and say, okay, now we know what time they must finish at. So that's how we get d equals 80.